In the silent, unending darkness between the stars, our solar system is an island of light in a cosmic ocean of unimaginable size. For millennia, we believed we were alone in this vastness, a self-contained cosmic snow globe, sealed off from whatever lay beyond. We were wrong. In 2019, our telescopes caught a phantom, a ghost from another world, screaming through our planetary neighborhood at an impossible speed. It was not from here. Its path was a scar carved across our sky, a trajectory that proved it came from the abyss, from the court of another star, countless light years away. Scientists named it 3I/ATLAS, and as they studied its strange alien glow, a chilling realization began to dawn. This was no ordinary comet. This was a messenger, and we have no idea what secrets or what horrors are locked inside its heart of ice. Prepare yourselves. The story of this terrifying visitor will change everything you thought you knew about our place in the universe. Across the surface of our planet, under dark and lonely skies, a network of robotic eyes keeps a sleepless vigil. They are the Asteroid Terrestrial Impact Last Alert System, or ATLAS. These sentinels, twin telescopes, stationed in Hawaii and Chile, are our planet's silent guardians. Night after night, they scan the heavens, their primary mission a grim one: to hunt for killers. They search for asteroids and comets, the rogue chunks of rock and ice born in our own solar system, that might one day cross Earth's path, threatening a cataclysm of civilization-ending proportions. They are designed to find the familiar monsters, the dangers lurking in our own cosmic backyard. But on a late autumn night in 2019, Atlas saw something else. It wasn't a monster, it was a ghost. At first, it was nothing more than a whisper of light, a single, insignificant pixel on a digital sensor, so faint it could have been dismissed as cosmic ray interference. A momentary glitch in the machine, but the ATLAS software is relentless. It saw the pixel again in the next image, and the next, it had moved. A new object had entered the catalog, logged with a sterile, unassuming designation. But as automated systems across the globe began to track this newfound wanderer, a quiet, professional curiosity among astronomers began to curdle into something else. A profound sense of unease. Something about this object was deeply, fundamentally wrong. To understand why, you must first understand the rhythm of our solar system. Imagine our sun not as a star, but as a colossal whirlpool in the fabric of space and time. Its immense gravity has sculpted everything around it. The planets from Mercury to Neptune are like ships caught in a calm, predictable current, sailing in near-perfect circles, bound to their star for eternity. They follow elliptical paths, a cosmic dance choreographed by gravity. Far beyond them, in the cold, dark frontier of our system, lies a vast spherical shell of trillions of frozen comets, a celestial kingdom of ice known as the Oort Cloud. This is our solar system's deep freeze, the source of our own comets. Every so often, a gravitational nudge from a passing star or the tide of the galaxy itself will dislodge one of these icy bodies. It begins a long, slow fall toward the sun, a journey that can take millions of years. It falls into the whirlpool. As it gets closer, the sun's heat begins to boil its surface, and it grows a magnificent tail of gas and dust. It swings around the sun in a long, stretched-out ellipse, a celestial slingshot, before being flung back out into the darkness from which it came. Its path is predictable. It is a known quantity. It is one of ours. But the ghost that Atlas found was not playing by these rules. As observatories around the world fixed their gaze on the newcomer, astronomers began to plot its course. They fed the data points, its position, its speed, its direction, into powerful computers. They expected the program to spit out a familiar elongated ellipse, the signature of a comet from our Oort Cloud. The answer that came back was not an ellipse, it was a hyperbola. This single mathematical curve changed everything. An ellipse is a closed loop. It is the shape of something that is gravitationally bound, something that belongs. A hyperbola is an open-ended escape route. It is the trajectory of a cosmic bullet, an object moving so fast that the sun's gravitational whirlpool is utterly powerless to capture it. It was like watching a speedboat from another ocean entirely, roaring through a quiet harbor at full throttle. It would visit our sun once, for a brief, terrifying moment, and then vanish back into the interstellar void, never to return. The conclusion was inescapable. and it sent a shockwave through the astronomical community. This object was not from our solar system. It was an alien, an interstellar interloper, only the third one ever detected in human history. They named it 3I/Atlas. Somber interstellar, and the questions began to mount, each more unsettling than the last. The first question was about its speed. To break free from the gravity of a star like our Sun, an object needs to reach what we call escape velocity from our position in the solar system. That speed is a staggering 94,000 miles per hour, or about 26 miles per second. That's fast enough to travel from Los Angeles to New York in under 2 minutes. Our fastest spacecraft, the Parker Solar Probe, only achieved its incredible speeds by falling deep into the Sun's gravity well. But 3I/Atlas didn't fall into our system. It arrived already moving at a blistering 73,800 miles per hour relative to the Sun. It didn't need our Sun's gravity to accelerate it. It brought its own velocity from whatever distant unknown star system had ejected it. It was a cosmic cannonball that had been traveling through the dark for millions, perhaps billions of years. Think of it this way. Imagine you are standing by a quiet pond. The water is still. Occasionally, a leaf from a nearby tree falls onto the surface, creating gentle ripples. You know the leaf came from the tree. You understand its origin. Now imagine that without warning, a perfectly smooth, dark stone, unlike any rock in the area, skips across the entire pond at an impossible speed and vanishes into the woods on the other side. You did not see who threw it. You do not know where it came from. All you know is that it was not from your world, and it was moving with a force you cannot explain. That is what astronomers felt as they looked at the trajectory of 3I/Atlas. This ghost wasn't just a point of light anymore. It was a physical artifact from another world, and unlike the previous interstellar visitor, the bizarre, cigar-shaped Oumuamua, which was a dark, inert mystery, 3I/Atlas was very much alive. As it drew closer to the Sun, it began to heat up, and it developed a coma, a fuzzy atmosphere of vaporized gas and dust. It was a true comet, but an alien one. This is where the fascination began to mix with a profound sense of dread. A comet is a time capsule. The comets in our own Oort Cloud are pristine relics from the formation of our solar system, 4.6 billion years ago. They are made of water ice, frozen carbon dioxide, methane, ammonia, and dust, the raw ingredients that built Earth and every other planet in our system. By studying them, we study our own history. But we knew nothing about the history of 3I/Atlas. What was it made of? Did the star system it came from form out of a cosmic cloud with the same chemical composition as our own? Or was this comet a chemical freak, composed of exotic ices and materials never before seen by science? Its light could be analyzed with spectrographs, tools that break down light into a rainbow barcode, revealing the chemical fingerprints of its constituent elements. Every astronomer on Earth wanted to point their best instruments at this object, to read the message it was carrying across the interstellar gulf. Because the message it carried could be the most profound in human history. It could tell us if the chemistry that led to life on Earth is common throughout the galaxy, or if we are a cosmic fluke. And what if it carried more than just chemistry? The theory of panspermia suggests that life itself could be transported between star systems, sheltered from the harsh radiation of deep space inside icy comets. For decades, it was pure speculation. But now, a vehicle for that very process was right here, in our own solar system. A delivery package from an unknown sender. Scientists weren't terrified that 3I/Atlas would hit us. Its trajectory was clear. It posed no threat. The fear was something far more cerebral, far more existential. It was the fear of the unknown. The universe had just proven that the gulf between stars was not an impenetrable barrier. The islands in the cosmic ocean were not isolated. Things could cross the void, and if a simple icy comet could make the journey, what else could? This visitor shattered our sense of security. It was a confirmation that our solar system was not a sanctuary, it was a crossroads. And we, humanity, were standing right in the middle of it, suddenly aware that we may not be alone. The ghost was here, and its secrets were about to be unveiled. But as our telescopes watched, mesmerized, the alien comet began to do something that no one expected. It was not just a messenger, it was a performer. And it was about to put on a show that would deepen the mystery and the terror 100-fold. As 3I/Atlas continued its plunge towards the Sun, a star system it had never known. Astronomers worldwide braced themselves. This was their chance, a once-in-a-lifetime opportunity to study an object from beyond our celestial shores. Telescopes, both on Earth and in orbit, were pointed with laser precision, eager to capture every photon, every whisper of information carried on the solar wind from this enigmatic visitor. The excitement was palpable. This was science in real time, an unfolding drama playing out across millions of miles of unforgiving space. The initial observations were fascinating. 3I/ATLS was clearly a comet with a distinct coma and a developing tail. Its chemical composition, glimpsed through the blurry data of early spectrographic analysis, seemed to resemble our own comets in some ways. Water ice, carbon dioxide, familiar elements. Perhaps the building blocks of other star systems weren't so different from ours after all. A wave of relief, coupled with profound scientific curiosity, washed over the community. This was still alien, still extraordinary, but perhaps not as utterly bizarre as Oumuamua, the previous interstellar object that stubbornly refused to categorize itself as either comet or asteroid. Then, in early 2020, as the comet reached its closest approach to the Sun, something utterly unprecedented happened. The 3I/ATLS began to brighten. Not gradually, not predictably, but explosively. It was as if a cosmic switch had been flipped, or a hidden fuse had blown, igniting an internal fire that swelled its luminosity by a staggering factor of 4,000. In a matter of days, it went from a faint, ethereal smudge of light to an object easily visible with binoculars, even challenging the naked eye under dark skies. This wasn't just brightening, it was a cosmic flash. Imagine holding a tiny dying ember in your hand. You expect it to slowly fade into nothingness. Now imagine that ember in a split second erupts into a blinding flare, momentarily outshining a stadium full of floodlights. That was the scale of the brightening of 3I/ATLS. It was as if the comet itself had decided to announce its presence to the entire solar system, a dramatic, fiery declaration from the interstellar void. This rapid, intense brightening immediately puzzled scientists. While comets do brighten as they approach the sun and their volatile ices sublimate, or turn directly from solid to gas, this was far beyond the norm. It suggested something far more energetic, far more violent was occurring beneath its surface. The leading theory was an outburst event, where pockets of highly volatile ice, perhaps trapped beneath a crust of less active material, suddenly exploded outwards, releasing vast quantities of gas and dust into space. It was like a champagne cork popping on a cosmic scale, releasing untold pressures from within. But the brightness wasn't just surprising, it was unstable. Just as quickly as it flared, the comet began to dim, then flare again, then dim. It was behaving erratically, like a flickering candle in a hurricane, or a dying star struggling for its last gasps of life. This unpredictable behavior deepened the mystery. Our solar system's comets, while capable of outbursts, generally follow more predictable patterns. This alien seemed to have its own inexplicable rhythm. And then, the ultimate twist. After its spectacular performance, as it began its long journey out of our solar system, 3I/ATLS didn't just fade, it disintegrated. Over the course of a few weeks in April 2020, observations from the Hubble Space Telescope, with its unparalleled clarity and resolution, revealed a horrifying sight. The once bright unified nucleus of 3I/ATLS began to fracture. First, it split into two distinct pieces. Then, those two pieces became four. Then, four became a multitude, a chaotic swarm of icy fragments, scattering across the emptiness like shards of a broken mirror. By the end of the month, the comet, which had traveled unimaginable distances to visit us, had completely fallen apart, dissolving into a diffuse cloud of dust and gas, a cosmic suicide. This dramatic self-destruction left astronomers speechless. Where comets can sometimes break apart, especially very old ones, or those making very close passes to the sun, this was an interstellar object, presumably pristine, and it wasn't even exceptionally close to the sun when it began its demise. It was as if it had held itself together for billions of years, only to unravel precisely at the moment of its grand debut. The disintegration was the final terrifying piece of the puzzle, and it plunged the scientific community into a maelstrom of theories and unsettling questions. What force had held this comet together for eons? only for it to fall apart upon meeting our star. Was it structurally weak? Was it made of materials far more fragile than our own comets? Or was there something else, something internal, something alien that caused its spectacular demise? One compelling theory centered on the idea of supervolatiles. These are elements or compounds that freeze at extremely low temperatures, even colder than water ice. Imagine a material that is frozen solid at temperatures hundreds of degrees below zero, temperatures found only in the deepest, darkest corners of interstellar space. When such a material encounters the relatively balmy conditions of our inner solar system, even at distances where water ice only slowly sublimes, it would erupt with incredible violence. It would be like taking a block of solid nitrogen, which boils at minus 196 degrees Celsius, and dropping it into a warm bath. The resulting explosion of gas would be instantaneous and powerful. If 3I/Atlas was rich in such supervolatiles, perhaps exotic forms of methane, carbon monoxide, or even nitrogen ice that are rare in our own solar system, then its bright flare and subsequent breakup could be explained. The initial brightening was the violent outgassing of these exotic ices. The subsequent dimming and flaring were smaller pockets erupting, and the final disintegration was the core itself being torn apart by these internal explosions, like a pressure cooker violently bursting open from within. But if this was the case, what did that say about the star system it came from? It would imply a formation environment far colder, far different from our own, a stellar nursery where temperatures plunged to unimaginable lows, preserving these alien ices for billions of years. It would mean that the chemical recipe for planets and comets elsewhere in the galaxy could be vastly different, creating worlds and cosmic wanderers that defy our current understanding. The terror wasn't just about the unknown composition, but it was about the implications. If interstellar objects are regularly traversing the galaxy, and if they can carry such extreme chemistry, what else might they be carrying? We think of interstellar space as a sterile vacuum, a barrier against life. But if a comet can survive for billions of years, carrying strange, supervolatile ices, could it also carry the seeds of life, protected deep within its fractured core? And if so, what kind of life would evolve in a system that could create such an extreme object? The destruction of 3I/ATLS, while visually stunning, was also scientifically frustrating. It was like finally getting a letter from an alien civilization, only for it to burst into flames before you could fully read its contents. The precious, pristine material from another star system was now mostly dust, too diffuse to analyze in detail. The messenger had shattered, taking most of its secrets with it. Yet, its brief, fiery visit left an indelible mark. It forced us to confront the fact that our solar system is not isolated. It is permeable, and the materials, the chemistry, perhaps even the life of other star systems can and do visit us. This realization, more than any other, has left scientists both profoundly awed by the sheer variety of the cosmos and deeply unsettled. Because if 3I/ATLS was just a fragile, icy fragment, easily destroyed by the warmth of our sun, what might be the next visitor, and what might it be made of? The ghost had departed, but its message lingered. The universe is far stranger and far more connected than we ever dared to imagine. And this was only the beginning of our journey into the terrifying truths hidden within the interstellar darkness. When an object of immense scientific importance is lost, the investigation does not simply end, it intensifies. The disintegration of 3I/ATLS was a catastrophic loss of data, but it was also, in its own way, a clue. The violent manner of its death was a form of cosmic autopsy. By studying how it died, we could begin to piece together the secrets of its life. Its self-destruction told us that it was not just an object from another star system. It was an object built on fundamentally different principles, forged in an environment alien to our own. To grasp the enormity of this, we must first journey back to the birth of our own sun. 4.6 billion years ago, there was no Earth, no Jupiter, no solar system. There was only a vast, cold, dark cloud of gas and dust, a stellar nursery. This cloud contained a specific recipe of ingredients, dictated by the generations of stars that had lived and died before it. It was mostly hydrogen and helium, the primordial elements forged in the Big Bang. But it was also seasoned with heavier elements, carbon, oxygen, nitrogen, silicon, all cooked in the nuclear furnaces of long-dead stars and blasted into space by supernova explosions. Imagine this primordial cloud, as the raw dough for a cosmic baker. Gravity was the baker's hands, slowly gathering the dough into a dense spinning ball at the center. This ball grew hotter and hotter until nuclear fusion ignited, and our sun was born. The leftover material, the scraps of dough and cosmic flour, formed a flattened, rotating disk around the newborn star. From this disk, all the planets, asteroids, and comets would form. The ingredients were fixed from the very beginning. The comets of our Oort Cloud are like frozen, leftover samples of that original dough, preserving the precise chemical recipe of our solar system's birth. That recipe is dominated by water ice, frozen carbon dioxide, and ammonia. The ghost comet, 3I/Atlas, did not come from our batch of dough. Its violent, explosive disintegration strongly suggests it was baked with a different recipe, one much richer in what we call supervolatiles. These are compounds like frozen carbon monoxide and molecular nitrogen. Let's use a more terrestrial analogy. Think of the ices in our comets as being like regular water ice cubes from your freezer. If you take an ice cube and set it on a warm countertop, it melts. If you heat it more, it boils. The process is relatively gentle. Now imagine a substance that is only solid at temperatures far below anything experienced on Earth, say -200 degrees Celsius. This is the equivalent of a supervolatile. Taking this exotic, super-frozen material and moving it to the warm countertop of our inner solar system is like dropping a stick of dynamite into a bonfire. It doesn't just melt or boil, it explodes. The rapid, uncontrollable sublimation of these materials would have exerted immense pressure on the comet's internal structure, tearing it apart from the inside out. The numbers here are staggering and paint a picture of an alien deep freeze. Water ice. The primary component of our comets forms at a relatively warm 0 degrees Celsius. Carbon monoxide, a suspected major ingredient in 3I/ATLS, doesn't freeze until the temperature drops to a mind-numbing -205 degrees Celsius or 68 Kelvin, just a few dozen degrees above absolute zero, the theoretical point where all atomic motion ceases. Molecular nitrogen, another potential culprit, freezes at an even more frigid -210 Celsius. For a comet to be rich in these substances, it must have formed in a region of its home star system that was far, far colder than the region where our own comets formed. It hints at a stellar nursery that was either vastly larger and colder than our own, or one with a fundamentally different chemical makeup to begin with. The ghost of 3I/Atlas was not just a visitor, it was a refugee from a colder hell, a realm of perpetual twilight, where the very air we breathe would freeze into solid rock. This discovery is terrifying because it shatters our assumptions about cosmic uniformity. We used to believe that most star systems would be broadly similar to ours, built from the same general Lego blocks. 3I/Atlas suggests that the universe is far more diverse. It implies the existence of star systems where the fundamental chemistry is alien. What would planets in such a system look like? Could a world form with vast flowing oceans of liquid nitrogen? Could it have an atmosphere thick with carbon monoxide, a gas that is lethally poisonous to humans? The comet's autopsy tells us that such worlds are not just possible, they are likely, and the plot thickens when we consider our only other confirmed interstellar guest, 1I/Oumuamua. If 3I/ATLS was a fragile, explosive ghost, Oumuamua was a rock-solid enigma. It was a dark, reddish, cigar-shaped object that tumbled end over end. Crucially, it showed no cometary activity whatsoever. As it passed by our sun, it didn't release a tail of gas or dust. It was completely inert, yet something was gently pushing it, causing it to accelerate away from the sun in a way that gravity alone could not explain. It behaved like a comet, but it didn't look like one. So now we have two data points, two confirmed messengers from the void, and they are polar opposites. One is a volatile, self-destructing ball of exotic ice. The other is a dark, rocky, and inexplicably accelerating anomaly. Imagine trying to understand all the ships on Earth by observing just two. The first one you see is a massive modern aircraft carrier. The second one is a small wooden canoe. From those two examples alone, you would have no coherent picture of global naval technology. You would only know that the diversity is far greater than you could have possibly imagined. This is the situation astronomers now face. The galaxy has sent us two postcards, and they depict completely different worlds, This statistical absurdity suggests that the population of interstellar wanderers is a veritable zoo of cosmic oddities, a menagerie of objects so strange that our current science can barely comprehend them. The ghost's autopsy tells us it was born of extreme cold. But where is that frigid birthplace? Where did this cosmic journey begin? Tracing its path backward, through the gravitational maze of our solar system and out into the vast emptiness of the galaxy, is one of the most difficult feats of celestial mechanics ever attempted. But somewhere out there, in the star-dusted tapestry of the Milky Way, lies a star system that is missing one of its children. Finding that parent star would be the next great leap, a step that could transform our understanding of the universe from a study of our own backyard into a truly galactic science. The hunt for the ghost's home was on. Finding an object in the sky is one thing, determining its origin, when that origin lies in the unfathomable depths of interstellar space, is another entirely. It is one of the most daunting forensic challenges in all of science. With 3I/Atlas now reduced to a cloud of dissipating dust, all that was left was its trajectory, a ghostly set of footprints stamped across our solar system. The task was now to follow those footprints backward, out of our system, across millennia of travel, and into the star-dusted wilderness of the Milky Way to find its home. This is not as simple as rewinding a tape. To trace this path is to account for a universe that is in constant, violent motion. It is a celestial ballet of staggering complexity. First, astronomers had to perfectly subtract the influence of our own sun. As 3I/ATLAS passed through our system, the sun's immense gravity acted like a giant lens, bending its path. To find its true interstellar trajectory, they had to computationally unbend that path, a feat requiring immense precision and processing power. Once they had the pure straight line of its inbound journey, the real challenge began. That straight line points to a region of the sky where the comet came from. You might think the next step is simple. Look for a star in that direction. But this is where the cosmic chaos takes over. The ghost's journey didn't take days or years. It likely took millions of years, over a million-year timescale. The galaxy does not sit still. It is a roaring, spinning, dynamic whirlpool of 100 billion suns. Imagine trying to trace the path of a single bee across a continent. Now, imagine that every flower, every tree, the ground itself, and even you are all on separate high-speed trains moving in different directions. The bee's starting point is no longer where you see it. This is the problem of tracing an interstellar object. Our sun is hurtling through the galaxy at roughly 500,000 miles per hour. The star that ejected 3I/ATLAS is also moving, likely at a comparable speed, but in a completely different direction. To solve this cosmic puzzle, astronomers turn to our civilization's greatest map, the Gaia spacecraft. Gaia is a revolutionary mission by the European Space Agency, designed to chart the precise positions, motions, and distances of over 1.5 billion stars in our galaxy. It has given us a dynamic, three-dimensional movie of our local galactic neighborhood. With the Gaia data, scientists can do the impossible. They can rewind the galaxy. They can computationally reverse the orbits of millions of stars, sending them back in time to see where they were thousands, or even millions of years ago. The process is a painstaking hunt for a cosmic needle in a moving haystack. They take the ghost's inbound vector and project it back into the star field. Then they rewind the clock. As the star field shifts and flows backward in time, they look for a moment of intersection, a point in the distant past where the comet's path and a star's path crossed, a point where a star and the comet were in the same place at the same time. When this was done for the second interstellar object, 2I/Borisov, the search yielded a few tantalizing, albeit uncertain, candidates. But when the supercomputers finished their work on the trajectory of 3I/ATLAS, the result that came back was profoundly unnerving. There was no match. No star in the vast Gaia catalog, when wound back through the ages, provided a definitive point of origin. The trail went cold in the interstellar darkness. The ghost's footprints led back into the void and then simply vanished. This lack of a clear origin is in many ways more terrifying than finding one. It opens the door to possibilities that exist on the very fringes of our understanding. The first possibility is that 3I/ATLAS was not ejected from a star system at all. It may have been an orphan of the void, born from a rogue planet. Our galaxy could be teeming with planets that were thrown out of their own star systems during the chaotic early days of their formation. These worlds, some potentially as large as Jupiter, wander the eternal night between the stars, cold and alone. It is conceivable that these rogue planets could host their own systems of moons and comets. If so, 3I/ATLAS wasn't a messenger from another sun. It was a fragment from a dark, wandering world, a place that has never known the warmth of a parent star. Its chemistry of extreme cold would make sense in this context, born in a place of absolute zero, untempered by solar radiation. The second possibility is even more haunting. The comet may have come from a cosmic graveyard. It could have been ejected from its system millions of years ago, and in the intervening time, its parent star has died. Its home sun could now be a white dwarf, a city-sized ember of degenerate matter, slowly cooling in the darkness. Or it could be a neutron star, a hyperdense corpse spinning hundreds of times a second. Or most chillingly, it could be a black hole, a rupture in space-time that has devoured its own sun. We were visited by a ghost from a system that no longer truly exists. We saw a relic from a world that is now, for all intents and purposes, gone. The final possibility is perhaps the most profound. The comet's journey may have been so ancient, its voyage so long, that the subtle gravitational tides of the galaxy itself have warped and twisted its path beyond recognition. It may have been traveling not for a few million years, but for hundreds of millions or even billions of years. A true primordial wanderer, a leftover from a much earlier epoch of the galaxy's history. It is so old that its birth records have been completely erased by the relentless churn of the Milky Way. We are left with a chilling conclusion. We were visited by an object of unknown composition, from an unknown location, born of an unknown process. We have its autopsy, but we cannot find its birth certificate. 3I/ABLAS was not just a visitor, it was a foundling, a cosmic enigma whose past is as mysterious as the future of our universe. Its untraceable origin deepens the sense of existential dread. The things that pass through our cosmic home are not just strangers. They are phantoms whose very existence challenges our ability to map the cosmos and our place within it. They come from a darkness so deep and so old that it has swallowed their history whole. And it forces us to ask a new question. What is this darkness they travel through? What is the nature of the interstellar ocean itself? For most of human history, we have imagined the space between the stars as a perfect emptiness, a sterile, absolute void, a black nothingness that separates the islands of light. This is a comforting thought, in a way. It makes the universe tidy. But it is profoundly wrong. The space between the stars is not empty. It is a place. It is an environment. It is a vast, cosmic ocean, and it is filled with dangers that could annihilate a fragile traveler over the eons. The journey of 3I/ALAS was not a gentle drift through serene silence. It was a desperate battle for survival across a galactic wilderness. This wilderness is known as the interstellar medium, or ISM. It is the tenuous sea of gas and dust that fills the entire volume of our galaxy. To call it a sea is, of course, a metaphor for its scale, not its density. The interstellar medium is a vacuum so profound it makes the best laboratory vacuums on Earth look like a thick soup. On average, the space between stars contains just one single atom per cubic centimeter. To put that into perspective, the air you are breathing right now contains roughly 25 quintillion atoms in that same amount of space. The ISM is almost infinitely empty, but space is vast, and almost is a very important word in cosmology. Over light years, that thin, ghostly mist adds up. Think of it as a fog that pervades a continent. Common in most places, the fog is so thin you can't even see it, but it's there. And as you travel for thousands of miles, the cumulative effect of those tiny water droplets begins to wear you down. This is the ocean that 3I/ATLAS had to cross. And this ocean is not calm. It is a violent, chaotic maelstrom of radiation and high-energy particles. For millions of years, as the ghost comet tumbled through the dark, it was under relentless assault from cosmic rays. These are not rays of light, but actual particles, protons and atomic nuclei, that have been accelerated to nearly the speed of light by some of the most violent events in the universe, such as the titanic explosions of supernovae. These particles are microscopic bullets, and they riddle everything in interstellar space. They would have slammed into the surface of 3I/ATLAS, shattering molecules, breaking chemical bonds, and slowly, atom by atom, eroding its very substance. It was a constant cosmic sandblasting that lasted for an eternity. At the same time, The comet was bathed in the raw, unfiltered ultraviolet radiation from distant, hot young stars. This is not the gentle UV that gives you a sunburn. This is a hard, ionizing radiation that acts like a chemical scalpel, mercilessly slicing apart the delicate frozen molecules on the comet's surface. Water, methane, ammonia, all would be slowly decomposed by this invisible bath of stellar fire. Over hundreds of thousands of years, this constant bombardment from cosmic rays and stellar radiation has a profound effect. It cooks the outer layers of the comet. The more volatile, fragile ices are vaporized or transformed, and what's left behind is a thick, dark, inert crust, rich in complex carbon compounds. It is, in essence, cosmic scar tissue. The comet develops a suit of armor, a protective shield forged by the very harshness of the environment it is trying to survive. This dark reddish crust seals the pristine, exotic ices of its core away from the dangers of the void. This theory of a protective crust suddenly illuminates the behavior of both of our interstellar visitors. Oumuamua, the first visitor, was dark, reddish, and showed no cometary activity. Perhaps what we saw was an object with an incredibly thick, ancient, and battle-hardened crust. Its pristine volatiles were buried so deep that the brief warmth of our sun couldn't penetrate its armor. We were looking at the shield, not the heart. Timni Rai/ATLS. So, on the other hand, was the story of a shield that failed. It too would have possessed this protective crust. But perhaps its crust was thinner, or perhaps it had been fractured by a past collision in the void. As it approached our sun, the warmth began to seep through the cracks. Election, it reached the core, the alien core, packed with those super volatile explosives like frozen nitrogen and carbon monoxide. The result was inevitable. The pressure built up behind the dam of its crust until the entire structure failed catastrophically. The bright flash was the moment the armor shattered. The final disintegration was the comet's protected heart being violently exposed to the sun for the first time in millions of years. This realization is deeply unsettling. It means the objects arriving in our solar system are not as they were at their birth. They are fundamentally changed by their journey. They are survivors, veterans of an invisible war against the void itself. The interstellar medium is not a passive backdrop. It is an active participant in this cosmic story, a force that batters, erodes, and transforms everything that dares to cross it. The ghost that visited us was not just a messenger from another star. It was a battle-scarred mariner, its hull weathered by an ocean of radiation and time. And this leads to a truly terrifying question of statistics and probability. For centuries, we saw no visitors. Then, in the space of just a few years, our new, powerful telescopes detected two. This cannot be a coincidence. It must mean that the ocean of night is not empty. It is swarming with these wanderers. The ghosts are not rare exceptions. They are the norm. We had simply been blind to them. Now our eyes are open, and we are forced to confront the staggering number of unseen, silent travelers passing through our home right now under our very noses. The question is no longer if we will see another. The question is, how many are we missing? For the whole of human history, the night sky has been a canvas of reassuring regularity. The stars were fixed points of light, the planets familiar wanderers on predictable paths. The occasional comet was a fleeting visitor, but it was one of our own, a distant cousin from the cold edges of our solar system. The detection of Oumuamua and then 3I/Atlas shattered this illusion of celestial solitude. At first, they felt like miraculous, once-in-a-century events. But scientists soon came to a chilling realization. These visitors weren't rare at all. We hadn't won the cosmic lottery. We had simply, for the first time, opened our eyes. The logic that leads to this terrifying conclusion is a beautiful piece of statistical reasoning. It starts with a simple observation. Our sky surveys, like the Atlas system that discovered the ghost comet, are powerful, but they can only see a tiny fraction of the sky at any given time, and they can only detect objects above a certain brightness. Here is a powerful analogy to understand the calculation. Imagine you are standing in the middle of a vast, dark desert at night. You have no idea if there is any life out there. You take out a camera, point it in a random direction, and open the shutter for just 1/10 of a second. Later, when you look at the photograph, you see, to your astonishment, the blurred image of a single fox dashing through the frame. What can you conclude from this? The obvious conclusion is, there are foxes in this desert. But a scientist would go much further. A scientist would ask, how big was my camera's field of view compared to the whole desert? How long was my shutter open compared to a whole day? Given that I saw one fox in this tiny sliver of space, in this infinitesimal moment of time, the entire desert must be absolutely swarming with them for me to have been so lucky. My single photograph is proof of a massive, unseen population. The more telescopes are that camera. The solar system is that desert, E3. My/ATLA was that fox. By calculating the volume of space our telescopes were watching, and for how long they watched it before spotting an interstellar object, astronomers could estimate the total population density required to get that detection. The numbers they arrived at are difficult to comprehend, and they fundamentally change our perception of the solar system. At any given moment, right now, as you are watching this, scientists estimate that at least 1,000 interstellar objects larger than a few meters across are passing through the inner part of our solar system, inside the orbit of Jupiter. If you expand that volume to the edge of our solar system, out to the orbit of Neptune, that number swells to tens of thousands. Let that sink in. Our home is not a quiet, empty room. It is a cosmic beehive, buzzing with thousands of silent, unseen visitors from other stars. Most are too small, too dark, and moving too fast for our current technology to pick up. We are seeing only the very brightest, the ones that happen to fly right under the celestial streetlights of our most powerful surveys. For every 3i/ATLAS that flares up and announces its presence, there are thousands of others, dark and inert like Oumuamua, that slip by completely unnoticed. We are living in a sky full of ghosts, and we were blind to them until now. But this is just our solar system. If we extrapolate these numbers to the galaxy as a whole, the figures become truly astronomical, bordering on the supernatural. The Milky Way galaxy is estimated to contain something on the order of 100 quintillion of these wandering bodies. That is a 1 followed by 20 zeros. There are likely 100 times more of these interstellar nomads in our galaxy than there are grains of sand on every beach and in every desert on planet Earth. They are not an anomaly. They are a fundamental component of the galaxy. For every star that shines, there could be 100 million to a billion of these dark wanderers drifting in the void between them. The galaxy is not a collection of isolated star systems. It is a single vast ecosystem, bound together by a constant flowing river of rock and ice. The debris of 100 billion worlds exchanged over cosmic timescales. This is a paradigm shift in our understanding of the universe. The solar system is not a sanctuary sealed off from the rest of the cosmos. It is an open field in the middle of a galactic metropolis, with the traffic of countless other systems constantly passing through. The very dust between our planets is not entirely our own. A fraction of it is the ground-up remains of alien comets and asteroids. We are, in a very real sense, breathing in the remnants of other worlds. The barrier we imagined between our home and the great unknown is an illusion. This constant, invisible swarm forces us to confront a deeply unnerving and practical question. We spend a great deal of effort tracking comets and asteroids from our own solar system, because we know that a large enough impact could cause an extinction-level event. We have cataloged thousands of these near-Earth objects, and we track their orbits with religious precision. But we have absolutely no catalog of the interstellar swarm. They obey different rules. They come from unexpected directions, and they travel at much higher speeds. An object from our own solar system might impact Earth at a speed of 45,000 miles per hour. An interstellar object, carrying its own velocity from its home star, could strike us at speeds exceeding 150,000 miles per hour. Since the energy of an impact increases with the square of the velocity, an interstellar impactor would be exponentially more destructive than a domestic one of the same size. It would be the difference between being hit by a car and being hit by a cannonball. The ghost of 3i/Atlas was never a threat, but its discovery and the revelation of the teeming swarm it belongs to has opened our eyes to a new and terrifying cosmic hazard. The greatest danger may not come from the monsters we know, but from the ghosts we have only just learned exist. For decades, humanity has been aware of the existential threat lurking in the darkness of our own solar system. We have watched the heavens for rogue asteroids and comets, the wayward children of our own cosmic family. We've mapped their orbits, calculated their risks, and even practiced ways to defend ourselves. Missions like NASA's DART test, which successfully nudged an asteroid, represent our first tentative steps in building a planetary defense shield. We have a plan, however rudimentary, for the dangers we know. But 3i/Atlas and the invisible swarm it represents have revealed a new kind of threat, a danger for which we have no plan, no defense, and almost no warning. It is the threat of the cosmic bullet, an interstellar impactor. The difference between being hit by one of our own asteroids and being hit by an interstellar object is the difference between being struck by a fist and being struck by a rifle round. The deciding factor is one word: velocity. Objects in our solar system are all traveling in roughly the same direction around the Sun. An asteroid that crosses Earth's path might hit us in a cosmic fender bender at a relative speed of around 40,000 miles per hour. This is, of course, devastatingly fast. But an interstellar object is not part of our traffic. It is screaming through our system on its own trajectory, a cannonball fired from a distant, unknown cannon. It could strike Earth head-on at a combined velocity of 150,000 miles per hour or even more. The destructive power of an impact is governed by the law of kinetic energy. Energy equals 1/2 mass times velocity squared. The velocity term is the tyrant in that equation. If you double an object's speed, you don't double its destructive energy, you quadruple it. If you triple the speed, you multiply the energy by 9. An interstellar object moving just 3 times faster than a local asteroid would hit with 9 times the force. This is the brutal math that makes the interstellar threat so uniquely terrifying. Let's imagine a small, rocky object, just 100 meters across, similar in size to the famous Tunguska object that flattened over 2,000 square kilometers of Siberian forest in 1908. If an object that size from our own asteroid belt were to strike a city, it would be an unprecedented catastrophe, releasing the energy of a powerful hydrogen bomb. Now take that same 100-meter rock, but make it an interstellar traveler, hitting us at 150,000 miles per hour. The energy released would not be measured in megatons, but in thousands of megatons. It would be an explosion so vast, it would rival the simultaneous detonation of a significant fraction of all the nuclear weapons on Earth. It would carve a crater miles wide, instantly vaporize a major metropolitan area, and trigger global atmospheric and climatic effects. And 100 meters is still considered a small object. The physics of destruction are horrifying enough, but what makes this threat truly paralyzing is the problem of detection. Our planetary defense systems are designed to look for dangers along the ecliptic plane, the flat, disc-like region where all the planets orbit the Sun. It's like guarding a house by watching the front door and windows. But an interstellar object isn't bound by the ecliptic. It can come from anywhere. It could plunge down from the cosmic North Pole or scream up from the South Pole, directions in the sky where we are simply not looking with the same vigilance. It can come through the floorboards or phase through the ceiling. Worse still is the warning time. Because of its colossal speed, the window between our first possible detection of an interstellar impactor and the moment of impact would be terrifyingly brief. We track threatening asteroids decades in advance. An interstellar object might only become visible to our survey telescopes when it is already deep inside our solar system. The warning we would get might not be measured in years, but in months or weeks. What could we possibly do with only a few weeks of warning? Our only tested defense, a kinetic impactor like the DART spacecraft, is a gentle nudge. It relies on changing an asteroid's velocity by a few millimeters per second, an effect that only becomes significant over many years of travel time. Trying to use a DART-like mission on a high-velocity interstellar object would be like trying to stop a speeding freight train by throwing a tennis ball at it. The momentum would be simply too immense. The only other option discussed is the most extreme in the human arsenal, a nuclear weapon. The idea would be to detonate a powerful device near the object, not to shatter it, but to vaporize its surface, creating a rocket-like thrust that would push it off course. But the precision and timing required to pull off such a mission in a matter of weeks, against a target moving faster than anything humanity has ever launched, would be a feat bordering on the impossible. So we are left with a terrifying truth. We are living in a cosmic shooting gallery, and the deadliest bullets are the ones we can't see coming and have no way to stop. The threat is no longer a predictable monster that lives down the street. It is a ghost, a phantom assassin that could emerge from any direction at any time, with a power that dwarfs our own. This realization forces a darker, more philosophical question upon us. If our world is subject to this random, unstoppable threat, then isn't every world? Could it be that life, wherever it arises in the universe, is perpetually living under the shadow of a cosmic gun, and that the history of the galaxy is punctuated by the silent, instantaneous snuffing out of worlds by these cosmic bullets. The image we have painted is a grim one, a universe where planets are adrift in a cosmic shooting gallery, where civilizations can be snuffed out in a flash by a random bullet from the dark. This perspective frames the interstellar swarm as a potential great filter, a universal barrier that makes it incredibly difficult for intelligent life to survive for long. The universe, in this view, is a place that is actively hostile to life. But what if this is only half the story? What if the very same objects that act as cosmic bullets are also cosmic seeds? What if their primary role in the galactic ecosystem is not to end life, but to begin it? This is the essence of one of the most tantalizing and profound ideas in science, the theory of panspermia. Panspermia is the hypothesis that life exists throughout the universe, distributed by meteoroids, asteroids, and comets. It proposes that life did not necessarily begin on Earth, but was delivered here from somewhere else. For decades, it was considered fringe science, but the discovery of interstellar objects like 3I/ATLs has dragged it into the mainstream. Suddenly, we have confirmed the existence of the delivery vehicle. A comet like 3I/Atlas is in fact the perfect vessel for transporting life across the interstellar void. Think of the challenges. The journey takes millions of years through a vacuum exposed to lethal cosmic rays and sterilizing stellar radiation. Life needs a lifeboat, a shielded sanctuary to survive the trip. That is precisely what a comet is. Its core is rich in water ice, the universal solvent, which would be gently delivered to a new world upon a soft enough impact or atmospheric breakup. Deep within this icy matrix, shielded by tens or even hundreds of meters of material, any dormant microbial life would be completely protected from the cosmic radiation that scours the comet's surface. The very scar tissue crust that we discussed, formed by the harshness of interstellar space, becomes a crucial life preserver, an armor for the precious cargo within. Furthermore, we know from studying our own comets that they are not just dirty snowballs. They are packed with complex organic molecules, amino acids. The building blocks of proteins have been found in meteorites. The chemical precursors to DNA have been found in laboratory simulations of cometary conditions. These objects are not just delivering water, they are delivering the entire starter kit for life, a prebiotic soup ready to be mixed on a new fertile world. Imagine a dandelion in a vast field, a gust of wind, or in our case, a giant asteroid impact on a life-bearing planet sends thousands of its seeds drifting across the landscape. The vast majority of those seeds will land on barren rock or in sterile water and will never germinate. But a tiny, statistically insignificant fraction might, by sheer chance, land in a distant fertile garden. An interstellar comet is a cosmic dandelion seed. The galaxy is the field, and with quintillions of these seeds drifting through the void, it becomes statistically inevitable that some of them will land in a garden. This theory reframes the entire narrative of 3I/ATL. Its violent, self-destructing nature, driven by supervolatile ices, might be part of the delivery mechanism. Such a fragile object would be more likely to break up high in the atmosphere of a planet, a cosmic airburst that would gently sprinkle its chemical and biological payload across the surface, rather than blasting it all away in a cataclysmic impact. It was a fragile seed pod, designed to burst at the right moment. The sheer number of these wanderers transforms panspermia from a wild possibility into a near certainty. If life arises just once in a single star system in our galactic neighborhood, and that system begins ejecting comets and asteroids, it would inevitably begin to seed all the surrounding systems. Life doesn't have to win the lottery by starting from scratch on every single planet. It only has to win it once. After that, the galactic delivery service takes over. This leads to a question that cuts to the very core of our identity. We think of ourselves as Earthlings. All of our history, our evolution, our biology is tied to this planet. But is it? If panspermia is the dominant method of life's propagation, then the original spark of life that led to every living thing on this planet, you included, may have occurred billions of years ago on a world orbiting a completely different star. That first single-celled organism, our oldest ancestor, may have spent 1,000,000 years frozen inside an icy prison, hurtling through the dark, before its voyage ended in the warm, welcoming oceans of a young Earth. This thought is both humbling and terrifying. It would mean that all life on Earth is, in fact, alien life. We are the descendants of interstellar travelers. The ghost comet 3/ATLAS wasn't just a stranger passing in the night. It could have been a cousin, a messenger from the star system that seeded our own. Its arrival in our solar system was not a visit from a stranger, but a long-lost family reunion. And it forces us to wonder if the seeds of microbial life are so common, delivered by a constant rain of cosmic debris. Has that delivery service ever sent us anything more? Throughout this entire cosmic detective story, we have operated under one enormous foundational assumption that 3I/ATLAs and its predecessor, Umanumo, were natural phenomena. We have debated their chemical makeup and their frigid birthplaces, framing them as geological artifacts from other solar systems. But there is another possibility, one so profound it threatens to shatter our entire worldview. An idea so controversial that most scientists are reluctant to even speak its name. What if we are wrong? What if one of them, or both, were not natural? What if they were artificial? This is the precipice of a scientific revolution, and to understand it, we must first return to the enigma of the first visitor, Oumuamua. Its name is Hawaiian for a messenger from afar arriving first, and it behaved like no object we had ever seen. First, there was its shape. By measuring how its light reflected as it tumbled, astronomers deduced it was an object with an extreme aspect ratio, at least 10 times longer than it was wide. This is not the lumpy potato shape of a typical asteroid. It is the shape of a cigar, or perhaps more likely, a flat, thin pancake. While not impossible for a natural object, it is a highly efficient shape for an interstellar spacecraft, designed to minimize collisions with dust at high speeds. Second was its behavior. It was completely inert. As it whipped around the sun, it produced no coma, no tail. It was not an icy comet. Yet, and this is the single most inexplicable fact, it was accelerating. As it departed our solar system, something was pushing it, causing it to deviate from a path dictated by gravity alone. The push was gentle, but it was undeniable. Comets accelerate all the time due to the rocket-like effect of their outgassing jets. But Oumuamua had no jets. It was a ghost ship, its engines running silent. This led a handful of prominent scientists, most notably astronomer Avi Loeb of Harvard University, to a startling hypothesis. The push on Oumuamua was perfectly consistent with the pressure of sunlight itself. If the object was not a dense rock, but an incredibly thin, lightweight surface, the photons streaming from our sun would push on it, just as wind pushes a sail. They proposed that Oumuamua was a solar sail, a piece of advanced technology created by an extraterrestrial intelligence. It is a technology we are trying to develop right now for our own interstellar probes. Imagine a still day. A rock and a leaf are dropped from a tree. The rock, dense and heavy, falls straight down, its path dictated only by gravity. The leaf, broad and light, is caught by the faintest breeze and drifts sideways. Oumuamua acted like the leaf. Every other asteroid and planet acts like the rock. Its anomalous acceleration was the breeze, and the sunlight was the wind. Now, we must turn this terrifying lens on 3I/Atlas. On the surface, it seems a poor candidate for an artifact. It looked like a comet. It acted like a comet. It flared up and grew a tail. But what if this was a disguise? What if its dramatic, explosive death was not the natural disintegration of a fragile, icy body? Consider the sheer violence of its end. It brightened by a factor of 4,000. It didn't just crumble. It detonated, flying apart with immense energy. Could this have been a technological failure? Perhaps we were witnessing a catastrophic engine overload as a probe attempted to adjust its course. Or, in a more paranoid and chilling scenario, could it have been a deliberate self-destruct sequence? A pre-programmed protocol designed to prevent its technology from falling into the hands of a curious emerging civilization like our own, triggered by its detection. The ghost that committed suicide in our skies might have done so to protect its secrets. This is the terror of intent. A natural comet is a mindless thing. Its path is governed by physics. It poses a threat, but it means us no harm. It is a force of nature, like a hurricane or an earthquake. But an artifact implies a mind. It implies purpose, a probe, a messenger, a piece of technology. This implies a creator. If Umamal was a probe, we were not just visited, we were scanned. Our solar system was surveyed by an intelligence we cannot comprehend. If 3I/ATLAS was a self-destructing artifact, It means that intelligence did not want to be found. Both possibilities are equally humbling and equally terrifying. Of course, the principle of Occam's razor tells us that we should not invent extraordinary explanations when ordinary ones will do. The vast majority of scientists believe that a natural origin is far more likely. Theories have been proposed to explain Oumuamua's push naturally, such as the outgassing of invisible hydrogen ice, or that it was a nitrogen iceberg, a fragment chipped off a Pluto-like planet in another star system. These are clever ideas, but they too require exotic, never-before-seen types of objects. And so we are left on the knife's edge of the greatest question in science. For the first time in human history, we have observed objects in our own solar system whose behavior is so anomalous that the possibility of an extraterrestrial technology is being debated in the peer-reviewed pages of scientific journals. The ghosts that haunt our skies have forced us to confront the most profound of possibilities. The question is no longer just, are we alone? It is now, are we being watched? We began this journey with a single mysterious phantom of light, a fleeting visitor named 3I/ATLX. We followed its impossible path, witnessed its spectacular death, and performed a cosmic autopsy on its remains. That single ghost has led us on an extraordinary voyage. It has forced us to confront the violence of the void, the true population of the interstellar darkness, and the terrifying efficiency of cosmic bullets. It has compelled us to consider that the spark of life on our own world may be alien in origin, and that the bringers of that life may also be the bringers of our doom. And finally, it has dragged us, kicking and screaming, to the very edge of science fiction, forcing us to ask whether the strange visitors in our skies are the products of nature or the products of a mind. 3I/ETLS was not just a comet, it was a revelation. Its arrival, along with that of Oumuamua, marks a fundamental turning point in human history. We can now say, with certainty, that our solar system is not an isolated island. The great cosmic ocean is not uncrossable. We are living in an interconnected galaxy, and the traffic between the stars is constant. We have, without realizing it, entered a new epoch. We have entered the age of visitors. The haunting question now is, what comes next? For centuries, our discovery of these objects was a matter of pure dumb luck. We were like a lone watchman, occasionally glimpsing a strange ship on the horizon, but that is about to change forever. High in the Chilean Andes, a new, colossal eye is preparing to open to the universe. The Vera C. Rubin Observatory. This is not just another telescope, it is a planetary sentinel, a marvel of engineering designed to do something no other instrument has ever done. To conduct a decade-long movie of the entire visible night sky. Its vast mirror and the largest digital camera ever constructed will scan the heavens with a speed and sensitivity that is difficult to comprehend. If our current sky surveys are like a single security camera watching a single door, the Rubin Observatory will be a network of 1 million cameras, monitoring every window, every hallway, and every shadow of our cosmic house, all at once. When the Rubin Observatory comes online, we will no longer be waiting for years or decades to spot the next interstellar visitor. It will find them weekly, daily. We are about to go from a trickle of information to a raging flood. We will discover dozens, perhaps hundreds, of these objects every year. We will finally see the true diversity of the interstellar swarm. We will find more explosive ghosts like 3I/ATLAs. We will find more dark enigmas like Oumuamua. We will find objects stranger than either, wanderers whose properties will challenge our theories and ignite new, fiercer debates. We are standing on the shore, about to witness the arrival of an entire fleet, and this brings us to the final haunting truth. The discoveries of the past few years have fundamentally and permanently altered our relationship with the cosmos. Our sense of solitude is gone, shattered forever. We now know that the universe is not silent and empty, but a place teeming with the debris of other worlds. A place where the history of one star system can directly influence the destiny of another. The universe, we now know, is haunted. It is haunted by the ghosts of primordial chemistry, relics like 3I/ATLS carrying the recipe of their alien birthplace. It is haunted by the possibility of distant, intelligent minds, their motives hidden in the strange trajectories of artifacts like Oumuamua. Most profoundly, it is haunted by the new and unsettling knowledge of our own potential origins, the realization that our deepest roots may lie not in the soil of this earth, but in the icy heart of a messenger that arrived from a dead star billions of years ago. We look up at the same stars our ancestors did, but we see a different sky. We see not a serene and changeless void, but a dynamic, dangerous, and crowded wilderness. The terror of 3i/ATLS was never that it might hit us. The terror is the truth it revealed, that the door between our world and the great unknown universe has always been wide open. We were simply unaware. Now we know, and we can only watch and wait and wonder what will come through that door next.